So, all right, let's do this. I know, right? Okay, so your homework is just 4 quick problems, and then only do A and B. You don't have to do part C. Going through, I'm going to review a few things from yesterday. So this page, I think I added something in blue. So we talked about how to find your units. Then we talked about what your units are. And then we said for area, I discussed it, but now I want it written in your notes. When you find your area, it is some type of change. It is a change in whatever units you find, substitute that in here, and that's what the change is. So what I mean by that is, if I find my area, and it's 5, and the units are feet, it means I changed by 5 feet. So if I'm walking, I am now 5 feet ahead of where I started. If my answer becomes a change in 20 pounds, it means I'm 20 pounds lighter. The question you can answer is, how much do I weigh? It never tells you how much you actually have at the time. It tells you what has happened. So why is that confusing? Because you're going to see 20 feet, and then when I ask you, where am I at the time equal to 5, you're going to say 20 feet. You have to know where I was. Okay, so if they want to know that information, then they're going to tell you. So remember the question we did yesterday. We talked about, they told me we were at position x equal to 0. So I wrote it differently this time. Position s sub 0 is equal to 3. That the position at the starting time, the time was 0. And then it asked me what's my position when time is 2. So there's position at time it's 2. So you need to know where I was first, some position where I was first. Then I need to know how much I moved from time of 0 till time of 2. So that's what this graph does for us. When I estimate that area, that's how I figured out the 1.75. So I was at position 3. I gained 1.75 meters. So now I'm at 4.75 meters. Okay? We good? Because now I'm going to ask you a different question that's a little bit trickier. So I'm going to erase this, and I'm going to say off to the side here. Well, now I'm going to tell you at time equal to 1, I was at a position of 5. I want to know what's my position at 2. Okay, so I want someone to walk me through, and we won't have to calculate the whole thing. I want you to walk me through the information I would need to find that answer. Anyone? So at time equal to 1, I'm at a position of 5. I want to now know what's my position at 2 seconds later. So not at time equal to 1, at time equal to 2. Okay, Anthony, go ahead, give it a go. Uh-huh. And do what? Did I tell you to do? Well, however many subintervals, yeah. You want to do 2 of them? I'll do 2 of them. Yeah. It says 4? All right, we can do 4. All right. 1, 2, 3, 4 subintervals. Find those. Okay. Then you add it to 5. Perfect. So if I wanted to find the position at 2 seconds, I would need to know some starting position. The starting position I gave you this time was at time equal to 1. And then I would need to know the area from 1 until 2 only. So what you have over here is a graph of everything. If I only ask you from 1 to 2, then I only need the area from 1 to 2. So the confusion, again, is always understanding what this gives you. Because if I ask you where are you at time equal to 2, a lot of people will still go all the way back to 0 and do the whole area, even though I didn't ask you from 0. I asked you from time equal to 1. You want to be really careful with that. Are we good? Okay, so remember, whatever times you're using, you're doing the change in. here I would only need to know the change from time equal to 1 to time equal to 2 to figure out where I am. All right. That was that little guy. We talked about the inscribed and circumscribed. We're going to do one example today in class. So if you didn't get that, that's okay. So I believe we left off with this, correct? All right. Did we get any further than just question 1 and question apparently 1? Okay. So the next page. All right. So you're going to find your distance traveled during the 4 seconds. So if you listen to the way that was stated, the distance traveled in the 4 seconds, it only tells me what happens during the 4 seconds. So if I asked you, at time equal to 4, where are you? You would not be able to answer that. You could just tell me, oh, I moved however many feet in that time. So you really just want to think about, I tell you I moved 20 feet. Where am I? You can't answer that question. You always have to know where you were sometime. 20 feet away from where I started. So you always want to know where you start. All right. So finding the distance using a table, it's essentially the same exact thing as you doing a graph, only you won't have a graph. So I make kind of a fake graph. So if you remember when we started our RAMs, I made you kind of mark out where you would draw your rectangles. We're going to do the same thing. So I'm going to mark out the fact that we want 4 subintervals, and this goes 0 to 8 to 4. Then I'm physically going to draw that. It's going to be helpful. So I'm going to do that one in blue, this one in red, this one in pink, and then this one in orange. So why is that helpful? Because I'm going to be asking you to do LRAM, RRAM, MRAM, and so if you have them broken up, the first thing you can tell is the top is always going to be, your X values are always your width. Your Y value is going to be the height of your rectangles. So if I have my widths up top, then I'll be able to tell how wide each of my rectangles are. How wide is my first one? How wide is it? 1. How wide is the next one? 1. How wide is the next one? 1. And then 1. So this is extremely important, the fact that they're common. You want to know that they're common. Next thing, if I asked you to do an LRAM, given the first rectangle, where would my LRAM be? The left Y value is 0. How about if I did an RRAM? My right would be 11. What about MRAM? There's the middle. 4. So it goes in that order. So literally, you don't have to label all of them. I'm going to label them for your notes. So your left and right, they sometimes overlap. You should see that when you do your calculations. So if I'm asked to find my distance traveled during the 4 seconds with 4 subintervals, I would find an area. My area would be my common width. Multiply by all of my heights. So what are my heights? For my LRAM, they would be, in blue, 0. My red one would be 11. My pink one would be 32. And my orange one would be 56. So I use the colors to kind of coordinate so I know which ones I'm doing. Then you do your R and your M. Your RRAM, I'm still using my common width. My first one would be the right side, labeled 11. My next one would be 32. My pink one would be 56. And then my orange one would be 79. And then the middle, pretty obvious now. What was that again? Oh, 79 is the number, isn't it? All right, and then the last one. Middle would be 4. The red one would be 20. The pink one would be 44. And then the orange one would be 65. Whoa! Whoa! There it goes. Okay. I'm attacking people with my Promethean pen. All right. There we go. I'm not going to calculate the value. Put it in the calculator. Are we good? So now what I want you to do is set up the next problem, because the next problem has inconsistent intervals. I want you to use the exact same method that we just did, because in the end for this one, I believe you're going to do 4 subintervals again. 4 subintervals. I want you to do the exact same concept on this problem and finish off the parts. I think there's 4 parts total, or 3 parts. So start off. So, all right, so when you find area, how do we find units? Area? How? Not what. How do we find area units? How? The y unit times the x unit. That literally, we've been doing that over and over. I need you to actually remember these things that we go through. So your y unit, gallons per hour, times your hours. So you end up with gallons. How do you find your derivative units? Y unit over x unit, which if you just write the derivative, it'll show you what you're supposed to do. Gallons per hour. Dividing by hour is the same as multiplying by 1 over. So you get gallons per hour squared. Then in the next question it asks you to find LRAM, RRAM, MRAM using 4 subintervals. So I said keep with the exact same thing we just did. So first thing I asked you to do was go through and break up all your intervals. You're doing 4 of them. There are my 4. Next thing we did, we went through and found my widths. My first width was 1.5. My second width was 1.4. My third width was 1.1. And then my last width was 4. Then we went through and said, oh, it's a common width. Is that true in this case? No. So you just won't do the common width. You're going to have to do every rectangle on its own. That's the difference when you have inconsistent. It's kind of a pain. So if I do just the LRAM for my blue would be the 0. The RRAM later will be this guy, and the MRAM will be in the middle. So again, with my blue one, my LRAM would be, first rectangle has a width of 1.5 and a height of 0. My red rectangle would have a width of 1.4, but a height of 125. My pink one has a width of 1.1 and a height of 251. And then my orange one has a width of 4 and a height of 335. All right. So then if I do my RRAM, now you kind of see the pattern. You're doing the same thing whether it's consistent or inconsistent. The difference for consistent, you have to do every rectangle by itself. So my width is 1.5. My right rectangle, my red one would be a width of 1.4 with the right side being 251. My pink one would be a width of 1.1 and my right side being 335. And then my orange would be a width of 4 and my right side being 702. And then my very last one, my MRAM would be a same exact width, you'll notice, for every single one of them. 87, my red, let me get through this real quick, 1.4 with an M of 170. My pink would be 1.1 with 279. And then my orange would be 4 times 421. Okay? So again, your inconsistent intervals is a pain in the butt. Okay? Annie? Thank you. In the middle of that I noticed. All right. Yes. Okay. All right, we good? Concept questions? All right. So the values themselves, throw them in the calculator, you'll get them. The units we already discussed. So whatever the value is, all I know from this, so for your LRAM, I know using your LRAM value. Did anyone find the first one? Someone just find that first one so I have a number to use and discuss. Meaning throw it in a calculator real quick for me. Thank you, Annie. Thank you, Noah. Alice, did you finish it? No? Did you finish the value? No? Noah, did you finish it? Over. Malin, a little bit louder? 0.1. All right, and then the units were gallons. So just to make sure you understand what you found that in the first 8 seconds, the pool gained 1,791.1 gallons. Gained that much. I have no idea how much water is in the pool after 8 hours. I just know after 8 hours I gained this amount of gallons. Okay, so I don't know how much I have. I just know I have more by 1,791.1 gallons, approximately, because we're doing an approximation. Danny? In the first 8 seconds. Thank you. We are in the unit of hours. All right. So for each of them, same thing. It's an approximation, which is why you have 3 different answers. All right. Any questions on doing an inconsistent? I do believe it always helps to draw out the intervals and write the interval values on top and making sure you understand that represents the width of your rectangle and the y values are always the height of your rectangle. That way you'll have that each time. All right? So last thing that I'm going to have you do, we're going to look at over and under estimates. So this is not in your notes. What you can do is if you flip one more page, at the top there's a review, and it says review of 5.1. You're going to fill in that section there. So in your notes, there's a graph set of axes ready for increasing and decreasing. So what you're going to do, draw any graph that increases the whole time. Doesn't matter where it starts, doesn't matter where it ends, but it has to increase. You guys can actually go into that to the notes. There's physically axes there for you already. Okay. The function needs to increase the entire time. So do an easy graph. There are many you could do. I don't care which one you do. It just has to increase the entire time. All right, do a graph that decreases the entire time. And then from your increasing picture, I want you to draw one LRAM. Just one LRAM anywhere. Doesn't matter where in your increasing picture. Absolutely anywhere. Joshua Hun, your graphs are not increasing and decreasing. Sometimes they're constant, sometimes they're undefined, so they can't be used. It's okay. Just do a simple increasing graph. So draw yourself one LRAM. Then far away from it, draw yourself one RRAM inside that graph. Yep, you can do it for both. We will end up doing it for both. So draw yourself one LRAM and one RRAM for each. Because that will give you your answer to if it's an over or an under estimate. All right, so an increasing graph. I'll draw increasing and concave up. Decreasing, I'll do the same thing. I'll do a decreasing graph, but concave up. You could have done a constant, sorry, not constant, a linear function. That would be fine. You could have done concave down. That would have been fine. But you should notice, I only made you do one because you only need one to figure it out. If I draw myself an LRAM anywhere on my increasing graph, doesn't matter where, every time you draw yours, because every single one of you would have the same answer, your rectangle should always, for every single one of you, be underneath the curve. So if you drew all of them, you'll notice they're all underneath the curve. So your LRAM becomes an underestimate. Ramsey, put your head up all the way, please. Your RRAM, anywhere on the curve, pick a point, make it a right rectangle, not a left, and you'll notice it's on top of the curve. So your RRAM isn't over. What do you think happens when you decrease, though? It switches. So now this is going to be an over, but I am going to do it, and this one's going to be an under. So an LRAM, and actually let me label them. Left, and then my right. So I don't memorize these because you'll memorize them wrong. You'll just confuse them. So always draw it out. The thing you have to remember is that for RAMs, your over and under estimates are based off of increasing and decreasing functions. We don't care about concavity. So we're talking about f prime. That's all we care about. Okay? But when did we first hear about under and over estimates? When's the first time we heard about it? Linearization. So when you did linearization, though, there was an over and under estimate. What did we care about then? We cared about slope, true. Concave up versus concave down. Because if your function's concave up, your tangent line, no matter where you draw your tangent line, it's always under the curve. But if I do concave down, anywhere I draw my tangent line, my red lines, my tangent lines are always over the curve. So you want to make sure that you don't get them confused. So linearization, we talk about concavity. Okay? All right. Last thing. What time is it? 29. Perfect. All right. So we already did that. We're going to go to the last page. I want you to change numbers 3 and 4. You're going to change this to inscribed. And you're going to change this to circumscribed. You're going to change those. You're going to go back a page. Yeah. All right. So I would like for you to quickly, in like 4 minutes, try to draw out your rectangles. It tells you what to do for each and put in the units. You won't calculate the actual areas. I'm not going to have you calculate them. So for number 1, you're going to draw your RRAMs and then put in your areas. I am going to write the answer up here, and when you are done, you can check with me. So 5, and then an RRAM would be the right side. Pause this guy. All right, so, oopsie, no, I did the 10 wrong. It's 10, not 5. All right, so for your first one, it was 5 subintervals. They are over there. On your second one, I'll redraw it real quick. You want to make sure that you look and you are doing literally only what it says. I want someone to raise their hand and explain to me, why would some of my rectangles be above my curve in the first one, but then some of them be stuck underneath the curve in the second one? Noah? Because the graph does both increasing and decreasing is completely correct. Thank you. So here is my last one, which I messed up because I didn't do enough subintervals. Here it is. Let's see. There you go. No, for the last 2. I'm on numbers 1 and 2. I'm on top. All right, so your last 2, I changed to inscribed and circumscribed. Same thing. I would like you to follow the number of subintervals and do that. All right, so when you do your inscribed, you should notice they don't all end up being the same type of rectangle. In this case, you have a left, kind of a middle, a right, or sorry, I did that the wrong way. A right, and then a middle, and a right. So a right, a middle, a left, and a left. What I want you to understand, sometimes you don't even have that. Sometimes it hits the rectangle completely, not in the middle, not in the right, not in the left, some random spot. I can show you what that would look like if I change this graph and I say, oh, maybe I'll make it dip down here and then go up there. The rectangle I would have to draw to be inscribed would be that one. That's not a MRAM, that's not a LRAM, that's not a RRAM. So I don't want you to think that when you do your inscribed and circumscribed that they have to be perfectly left, right, or middle. They will be wherever makes what they want inscribed happen. So this point is not at the left, it's not at the right, and it's not at the middle. Okay? And then here to the right, I did circumscribe, so every single rectangle was above the curve, completely above the curve. Okay? Any questions? Yep. A person squared doesn't make sense. It's the rate of change, so it's kind of like the acceleration of the cost. How much the rate of the cost changes by. Okay? Alrighty. So homework, front page. There you go.